Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about Arrokoth secrets and other made-up phrases, and of course, taking listener questions about all beautiful things in this universe, because what else is there in this universe other than beautiful things? We record every Thursday at 8 p.m. Eastern, and you can follow along on our live stream or leave a voicemail at spaceradioshow.com. And in today's Blue Shift, I'll be talking about beware, the quote from the scientist. But first, the news. Hey, space cadets, welcome to Space Radio. I'm Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute. And for the next half hour, your agent to the stars. Got an exciting show for you today where we talk about all the amazing things in our universe, which is a lot. And this show lives on listener questions. We record every Thursday at 8 p.m. Eastern here in Spaceman Studios in New York City. So you can leave a voicemail at spaceradioshow.com to get yourself on the air. You can also follow along with our space cadets tuning in live from around the world. I am not joking about that. I'm not making up, who knows? I mean, people show up. I don't know where they could be down the street for all I know, but they say they're from around the world, and I take their word for it. Seriously, folks, I want you to send questions. This show lives on questions, like I said. Send me questions. I answer them. It's the show. It's just that simple. It's only astrophysics. I've only prepped 10 minutes of show material tops, so get those questions in. Space cadets, I've missed you. Sorry I missed last week. I wanted to do a show last week, but I had my 20th cold of the year, and I can push through a cold, I can do a show, but it was ripping my throat apart. And it was not pretty. It was just not pretty. No one wanted that, especially not you. I would remember a couple weeks ago where I was talking like this. It was worse. It was worse. Oh, good. Space cadets, I don't have any voicemails tonight, so I want you to get lots of questions in, okay? So, I've got cheese tonight, don't worry though. I'm smelling, it's over here, I unwrapped it, I've been smelling it the whole time I've been prepping. This is great. Get tons of questions in here, guys. I really want to see lots of questions. I'm not going to boss you around. You can do whatever you want, space cadets. But I would prefer some questions. Can we deal with that? Can we deal with that? I am asking you for some questions for me to answer on the show. And we've already got some going. Thank you guys. Let's do some news. And I'm going to talk about Arrokoth. Is that how you pronounce it? I don't even know. Before I start taking calls, I wanted to share some interesting bits of news I caught recently. And in the news this week is all about Arrokoth. Arrokoth, I don't know how to pronounce these words. Arrokoth. Arrokoth, I'm going with. Formerly known as Ultima Thule, formerly known as MU69 2014, something like that. It has the official designation of Arrokoth. It's a little object in the Kuiper belt, which is the leftover bits of our solar system. Icy debris that's just tossed around way at the outskirts. We're talking tens to hundreds of times further away from the sun than the Earth is. And the NASA spacecraft New Horizons visited Arrokoth over a year ago after it did its historic flyby of Pluto. There happened to be a Kuiper Belt object very close to its original trajectory. Slight change of course. They were able to do this flyby, the most distant flyby ever achieved by humanity. And I'm agreeing with the chat here with the Space Cadets. Ultima Thule sounded way cooler. But I'm not in charge of naming things as much as I want to be, so we're going to go with Arrokoth. Now, the cool thing about Arrokoth, if you've ever seen a picture of it, it looks like a peanut. It's two rocks that are glued together, not smashed together, and that's what's interesting after these detailed study, because all the papers were released from those initial findings now. These two objects weren't smashed together. They just kind of mwah, like a little Valentine's kiss. They touched and they glued themselves together. That bit of evidence, plus the fact that there aren't a lot of craters on Arrokoth, seems to suggest that it's relatively calm out there. It's not such a violent place. Remember, this thing of rock, of ice and rock, is 4.5 billion years old. This thing dates from the beginning of the formation of the solar system itself. And so it's a time capsule. You open it up, you look at the time capsule, and you get to learn what the universe was like back then. And you find out it was really, really chill. It was super low key. Some theories of planet formation are very violent, where there's little bits and they crash into bigger bits. And then the bigger bits crash into even bigger bits, and then bigger and bigger and bigger. And then so there's lots of crashing involved. But Arrokoth is like, nah, man, nah, cool. You know what? You want to form a planet, you just go on ahead. You just gather up the material. I won't bother you. We don't fully understand how planets form. There are a lot of competing theories of whether they crash into each other, pebbles crash into each other, or if it's more smooth and gentle. The existence of Arrokoth and its features seem to suggest that it's a little bit more on the gentle side, at least to start. As with most competing theories, usually the correct answer is a little bit of column A and a little bit of column B. So it looks like, at least to start, our solar system was gently accreting and gathering material, and then maybe it got a little bit more violent as it got bigger, as it entered puberty. Then it had some youthful indiscretions, but its childhood was relatively benign. So thank you, Arrokoth. Although you always be Ultima Thule in my heart. Remember to leave a voicemail or follow along with the Space Cadets at spaceradioshow.com. And that's the latest greatest when it comes to space. Let's answer some questions. Wow. Space Cadets. I bet you guys have some good ones. As I drink my seltzer here. Edward Hinton getting some good questions. Beetlejuice. Gosh, yeah. Good question, Arnetta. That's it. Campbell. Deorbiting. Yeah. Brian Green said there's a confusion in the early. There was something called repulsive energy. Good job. Okay, Nancy. I love this. Lots of good questions. We've got 2 segments of questions ready to go. We're going to rock this. We're going to rock this together, Space Cadet style. Do you like my new chalkboard? It's very new and it's very nice, and I'm very happy with it. We've got tons of Space Cadet questions ready to go, and I know you're excited as I am, so I'm just going to jump right in from the top, and we'll see. Some weeks I'm able to finish all of the Space Cadet questions. Actually, that happened once. I think that happened once when I devoted like less than a minute per question, 30 seconds per question. I was able to get all of them in. We'll see. We're just going to go. We're just going to live life as it comes, all right? And we're not going to make any judgments. We're not going to have any preconceived conclusions. We're just going to let it roll. Edward Hinton on YouTube, one of the Space Cadets, is asking, if we knew for certain that we are the only life in the universe, should we send probes filled with DNA and bacteria out into the cosmos? Well, first, if we were to find out that we were the only life in the entire universe, we would just need to have a sit down and a think about it, because that has some massive implications. Like the entire cosmos, all the stars you see in the sky, all the galaxies. We're talking hundreds of billions of stars per galaxy, hundreds of billions of galaxies in the observable universe. And we're the only ones? Talk about an existential crisis. Like, we're it, folks. Like, let's let that sink in first. But then you gotta ask, okay, is it our job to seed the universe with life? Well, I mean, it's not like anyone else has any claims to it, so we might as well. I don't know the best possible path to spreading life throughout the galaxy. Maybe it's space capsules filled with DNA and hope they crash on planets. That seems a little bit dicey. It's this whole panspermia idea. Man, it's hard to get living things lasting for tens of thousands of years. It's hard to get them to survive atmospheric reentry, and just plopping them down on a random bit of rock doesn't necessarily mean that they'll sprout. But we gotta figure out something. But hey, if we're the only ones, and we got the whole universe to play around in, and we've got plenty of time, and we managed not to kill ourselves, I'm sure we'll come up with a solution. I don't know what the best solution is, but that's somebody else's problem. Arnetta Davis over on YouTube is asking, I've been seeing a lot of questions about Betelgeuse because it's been fading and shrinking. Do you think it will go supernova? Okay, Betelgeuse, and I'm not going to say it 3 times. The star in the shoulder of Orion, it's a red giant star, easily visible with the naked eye. It is a red giant star. It's massive. If you plopped it in our own solar system, it would stretch to like the asteroid belt or something ridiculous. It is going to pop. It is going to go supernova any day now. Where any day now means astronomical day now, which means any million year from now. Maybe it'll be this million years. Maybe it'll be next million years. Maybe it'll be the 8th million years from now, but any million years from now. Betelgeuse is a red giant. Oh, I said it 3 times. Dang it. Fine. I'll just have to suffer the consequences of that. This star is going to go supernova. Is it going to go supernova tomorrow? Probably not. It might, but probably not. Is it going to go supernova this year? Probably. Like, exceedingly small chance that it will go supernova. It is doing some funky things. It is getting dimmer, a little bit dimmer than average, relatively quickly. But man, these big stars are just like the stars, the human stars. They are unpredictable. Sometimes they're worldwide and they're famous and they're blazing bright. And sometimes they're a lot quieter and just sticking to themselves. They're not in the papers a lot. Sometimes they're making news. Sometimes they're not. Sometimes these big stars are flaring and getting bright, and sometimes they're getting dimmer. They just do, okay? They're just a little bit unstable and unpredictable, and we just have to live with it. And what a cool testament to the era of astronomy that we live in, that we can watch a star evolve in real time. Day by day, we know how Betelgeuse is behaving on a very precise level. Am I the only one that thinks that's cool? No, because you should think that's cool too, all right? It's cool. We get to watch a star live and breathe. And so, of course, it's going to be news because it's going to be doing cool stuff every single day. And it's not the only star doing cool stuff every single day. So let's enjoy it. Let's go along on the Betelgeuse ride. I'm going to take a quick break, folks, before I start answering some more Space Cadet questions. I do not know how to speak good today. I'm Paul Sutter, and this is Space Radio. This show is brought to you by you. Please go to patreon.com/PMSutter to learn how you can keep the show going. And if you're one of those people who think, wow, I really like the show, I want to support, but I'm sure other people are supporting it. Yes, other people are supporting it. But so should you. If you want to, now's a good time. What are you waiting for? pmsutter.com. No, wait, that's my website. Patreon.com/pmsutter. You can also go to spaceradioshow.com, and there's a link to Patreon right there. I'll see you after the break. Space Cadets, do you think Betelgeuse is gonna blow? No, yes. Vote now. If it's not going to blow, can we make it blow? Can we shoot a laser at it? That Elon, what is that? The space laser that they're making for the spacecraft, the Starshot, whatever initiative? Can we just shoot that laser at Betelgeuse and make it blow up in 500 years? Now that's fun. I would support that. I would pledge to that. A giant space laser to blow up other stars. What could go wrong? All right, moving on. All right. I'm not even going to read further. I'm just going to go down the list and we'll do it. All right, I like a lot of disagreement amongst the space cadets. We'll see where it goes. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more Space Cadet questions ready to go, but remember, you can leave a voicemail or join the live stream Space Cadets here at 8 p.m. Thursday by going to spaceradioshow.com. I was looking at this stream from the Space Cadets. I asked them if they thought Betelgeuse is going to blow in the next, soon. Let's just call it soon. Very divided room. Half yes, half no. I proposed, if it's not going to do it on its own, can we make it blow up? Can we shoot a giant laser at Betelgeuse to make it blow up? How can we make this happen? Surely someone has the plans for it. Let's start blowing up stars for our own entertainment. Especially if we're the only life in the universe. Then let's do it. Let's just start. Hey, that star, I don't like the look of that star. You know what? I want a different constellation. Let's blow up that one. Who cares? No one's going to complain. Except some bits of rock. Speaking of bits of rock, we got a question here from the Space Cadets from Infinite Monkey over on YouTube. Does Arrokoth destroy the theory of violent planet formation? Arrokoth is what I talked about at the top of the show. This bit of ice and dust in the outer regions of the solar system. It's very gentle. It's very mild. It doesn't look like it had a violent past. Does this put to rest theories of solar system formation that rely on violence, on a lot of things smashing into each other? Yes, but kind of no, but kind of yes. The answer is it's much more nuanced and much more complicated than that. It appears that at least Arrokoth, or the outer bits of the solar system, formed initially very gently. But the gentle formation mechanisms don't get you big planets like Earth and Mars. You need a bit of violence to get a big rocky planet going. So maybe it's a little bit of both. Moving on to other Space Cadet questions. Campbell Duncan, are modern satellites required to have a way to deorbit themselves when their time is up? A lot of satellites can last for a very long time in orbit, especially if they're solar powered. If they don't have a lot of moving parts, if they're powered by the sun, they can just keep going and going and going. But eventually either they get decommissioned or defunded, or they do break, or something happens. And then what do we do with them? Nothing. Sometimes we intentionally deorbit a satellite, let it burn up in the atmosphere or plunk it down in the Pacific if it's big enough. But for the most part, we just let them hang out in space. We've been doing a very bad job at forward thinking in terms of satellites, because we always assume that there's more space up there. And it's just fine. It's just someone else's problem, whatever. Okay, we're done with the satellite. Okay, just leave it hanging because there's plenty of more space in space. Except when it's not. Except when we run out of space. Hopefully, future satellites will begin to employ this satellite. Yes, if it will have an end-of-life procedure. If the satellite's done, we're going to burn it up in the atmosphere. But right now, no. It's the Wild West up there. It is the Wild West. Nancy over on YouTube is asking, what are your thoughts or comments about Brian Greene's idea that there was a configuration of energy in the early instance in the universe that resulted in something called repulsive gravity? Repulsive gravity is a thing. You can have anti-gravity in our universe. It's just really, really tricky to get it. And so far in the present day universe, we only see it happening once, or in one place or one condition. We call that dark energy. The accelerated expansion of our universe is an anti-gravity. It is a repulsive gravity. We have no idea what's causing it. That's a separate show. But it exists. We believe that in the early universe, there was also a period of repulsive gravity, something we call inflation. Inflation made the universe much, much bigger in a very, very short amount of time. We don't know what caused inflation. We don't know how long it lasted. We don't know a lot of the details, but we're pretty sure something like inflation happened. It's the only way to explain certain kinds of observations that we're making of the early universe. So something definitely funky was up in the early universe. And like less than the first second, we're talking early. Something funky was up. We're not exactly sure what. Moving on, Alien of Soul 3, YouTube, is asking, I know planets can migrate inwards towards a star when they encounter gas and dust and slow down. Friction. Can a planet migrate outward away from a star? And if so, how? Yes, planets can migrate away from a star. But they can't do it they can do it by interacting with all sorts of things. It's all a game of gravity. If they get too close to a giant planet, the gravity of that giant planet can yank on them, can give them a boost, can give them some extra energy, and send it moving further out in the solar system and potentially out of the solar system altogether. We think that our 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, actually all 4 formed much closer together and much closer to the sun than they are today. Then Jupiter migrated inwards, and through that destabilization kicked the remaining 3 further out in the solar system until they eventually settled in their modern day configuration. So this was an interaction between Jupiter and the other giants that sent them migrating outwards. So it can happen. It can happen. It's a little bit tricky for it to happen, but it can definitely happen. In fact, this is how we think the Kuiper Belt itself formed, like objects like Arrokoth, we think formed much closer, but during this phase of outward planetary migration, all the material and debris that was left over also moved with them and got pushed into higher orbits. Edward Hinton over on YouTube is asking, how do we know any of our solar system planets are not captured from some other system, like some rogue planet wandering in and then we happen to capture it? The reason we think all of our planets in our solar system formed right here in the solar system is, one, they have a very similar abundance of, say, radioactive elements and certain percentages of elements. So it looks like we're all made of basically the same stuff. We came from the same soup. And the second is, capturing a planet is harder than you expect. A rogue planet that's just roaming the galaxy is traveling at an incredible speed. It has a lot of energy. And to actually capture it and settle it in a solar system is, one, very, very challenging, because the trajectories and the energies and the orbits have to line up just so in order to enable that capture. And then once a new planet is introduced, that it's like a bowling ball. It just wrecks other things in the solar system, can mess everything up. And we have no evidence of everything being messed up to that degree in our solar system. So as far as we know, all the planets in our solar system did form right here. The one exception is the hypothetical planet 9, which you may have heard of, and which I had just recorded some podcast episodes about this hypothetical planet 9 that potentially exists way out in the deep edges of the solar system. One possibility for how it got there is it's a captured rogue planet, but again, we're not even sure planet 9 exists. And if we did, that would be the subject for another show. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. That's right, I'm Galacticus. I'll take it. Yeah, maybe we just fill the universe up with robots. They could do all sorts of cool robot-y things. What was my Blue Shift? What am I talking? Oh, the quote from the scientist. Oh, here we go. I might get a little testy here. Planet 9. I honestly, you're hearing it from me, I don't think Planet 9's out there. Or if it is, I mean, it could be out there, but the evidence isn't very compelling to me. But that's me. And that's my thing. If it's interesting, it's probably wrong. Planet 9, the existence of Planet 9 would be interesting. Ergo, it's probably wrong. That's me. That's just me. Who am I? Poor country astrophysicist. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And I read news articles like, I don't know, once a month or something. And sometimes they're on topics of science, and sometimes they involve quotes from a scientist. Yeah, a little soundbite, a little bit of context, a little bit of this, a little bit of that. I want you to know that you should take any quote from a scientist that appears in a news article with a massive grain of salt. Not because the scientist is lying or trying to tell an incorrect truth, something incorrect or fabricating something, and not because the reporter is lying or the reporter is trying to slant something or the reporter is being unethical. No. It's all unintentional. It's all unintentional. I get interviewed every once in a while. Reporters reach out to me, ask me a bunch of questions, either by email or on the phone or Skype or something. And then the article comes out. And then I read the article and I say, hey, I wonder what I said. The quotes are always like accurate and faithful. They might be shorter versions of what I actually said, but they capture the essence. I've very rarely run into the case where a reporter has actually taken a quote and mangled it or put words in my mouth, something that's incredibly rare. But what I do see a lot is reporters, and I don't blame them, not understanding nuance or context of a particular situation. A reporter isn't an expert in science. Why should they be? They're an expert in reporting. And some of the topics they cover are detailed and nuanced and have a lot of views, and there is no yes or no, and it is actually a bit fuzzy. And sometimes I try to convey that nuance to say, well, yes, but blah, 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 and then the blah, blah, blah gets cut off. Or if I just say something cheeky or smart alecky, 99% chance that's what ends up being the quote because it sounds cool and it's a fun, juicy quote. Usually reporters, they're on a deadline. As Larry Beckham on the Space Cadet YouTube, one of the Space Cadets is saying, yeah, it's not bad reporting, or what we see as bad reporting is really just reporters having a lot of work to do and not a lot of time to do it. I cut them some slack. I still host interviews. I still provide quotes. But when you see a quote, know that it may not be the full picture. That's all. Is the show really over, guys? I don't believe it. This show went way too fast. Well, let's wrap up anyway. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Visit patreon.com/PMSutter to learn how you can keep this show going. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, and all the fine crew at WCBE Radio 90.5 FM in Columbus for making this show possible. Catch the live stream every Thursday at 8 p.m. Eastern and visit spaceradioshow.com for all the links and the live stream locations, Patreon, all that. And of course, thank you again, Space Cadets, for listening. I'll see you next week. And remember, science is for sharing. End of transmission. Time dilation is real. And you know what else is real? This cheese is going to get real right now. Cheese time. Is it everyone's? Guys, you're going to love this. Wow. Let me give you a little close up here. I already took it out of its wrapper. And the light, there it is. Can you see that, what I'm seeing? I have a Gorgonzola Dolce. Little Italian. I'm guessing dolce means sweet. I'm guessing that there's going to be the normal, robust, earthy intensity of the Gorgonzola, perhaps moderated by a little bit of sweetness. That's what I'm guessing. Now, one thing about this Gorgonzola Dolce, and check out the rind. Look at that. Rind. One thing about this that I need to say. I bought this cheese a couple weeks ago. It was wrapped in the store. It's been in the fridge. Should I be worried about it? Is it still good? I don't see anything obviously wrong with the cheese. Anything to worry about. I mean, there's mold, but that's the the mold in gorgonzola. It smells like gorgonzola, so I'm just gonna do it. I'm gonna do it. I'm gonna take a little corner. Oh, I don't know. Look at that. I want to show you guys. It looks like there's veins of like honey maybe in it. You see down here where I cut? You can't see that at all. Why could you? This is why I need my own cooking show. So I can shove cheese in people's faces. But there's like veins of something. I don't know. I'm going to eat it. If I die today, tell my family I love them. I will go. No, something's wrong. No, something's bad. Yes, I swallowed it. Nope. Wow. I've had gorgonzola. I love gorgonzola. This is a very strong gorgonzola, but there was a sharpness to it that I think I just ate penicillin. I hope it's penicillin. Oh my gosh, I have so many meanings. Oh my god. Yeah. That cheese was not in a good state. That was a massive, massive cheese fail. I think it used to be good. I'm out of water.